the functions of random variables. So here we have x, the mean is 25 and the variance 25, and y is equal to x minus 25 divided by 5. So you are required to find the mean and variance of y. Okay, so basically it is very easy, right? So you are trying to figure out what is the expectation of y and variance of y. So expectation of y is equal to x minus 25 divided by 5. Okay, so solution expectation of y is equal to 0.2x minus 5. Okay, and so what is that equal to? Actually, that is equal to 0. And what is Vy? It is V of 0.2x minus 5, because it is x minus 25 divided by 5, right? So x over 5 is equal to 0.2x. And minus 25 divided by 5 is equal to negative 5. Okay? So what you get? V of 0.2x minus 5 is equal to 0.4 times Vx. And that is actually equal to 1. As a matter of fact, x, if the mean, okay, is 25 and the variance is 25, and y is equal to x minus 25 divided by 5, that is equal to x minus mu x divided by sigma x. So actually that is the standardization of x. Okay? Questions? Give you 10 seconds to take the whole thing down. 10 seconds. It's not 10 minutes, only 10 seconds. All right. You need more. Up, okay, up, okay. Okay, any questions? Mr. Zheng, if you have difficulty looking at that, probably you should sit here. That should be easier, right? Okay, questions? Next one. So there are three factories, A, B, and C, right? The probability of being chosen is 0.2, 0.3, 0.5. So if I'm going to choose, right? So A, B, C, these three factories, they manufacture a lot of products. Okay, so the first I'm going to choose the factory. Okay, so the probability A being chosen is 0.2. The probability B being chosen 0.3 and C being chosen 0.5. And the product defect rate, okay, so the product may be good or bad, right? The bad rate is equal to 0.05, 0.07, 0.02. So if you choose any product from A, 95% gonna be good, but 5% will be bad. If you choose anyone from B, 93% will be good, 7% will be bad. And if you choose from C, 98% will be good, 2% will be bad. Okay? So now, if a defective item is chosen, okay, we already know this is good or bad. It is bad, okay? It is a bad one. What is the probability bad? This item come from A. So the girl there. So how to deal with this question? It's your turn. You know that? Yes. Good. So how to deal with this question? I beg your pardon? Would you please speak louder? No. We already know it is a defective item. And what is the probability this comes from A? And then The first thing, this is Bayes' theorem, okay? This is Bayes' theorem. So the first point, you need to know what is the probability it will be bad, right? It will be 0.2 times 0.05, okay? Because if you choose from A, how much is going to be bad? 0.05. And if you choose from B, how much is going to be bad? 0.07. Okay, so 0.3 times 0.07. And if you choose from C, 0.5, and times, what's the probability you're going to be bad? 0.02. These are the probability. I mean, when you add these together, it is the probability that whenever you choose, these will be the probability for the bad one, okay? So the probability you are going to get a bad one is 0.2 times 0.05 plus 0.3 times 0.07 plus 0.5 times 0.02. Okay, this is the probability it will be defective, right? So given that it is already defective, what's the probability it is going to come from A? So it is the number we just get, right? It is the denominator, right? And what's the numerator? The numerator is 0.2 times 0.05 and divided by the number we get, okay? So this is an application of Bayes' theorem. Okay, it is here. So you choose, you already know that is defective, so we use D to represent defective. And you are going to get from A. So defective item, and also you're going to get from A. Okay? So basically this is the question, very easy, and the answer is even easier. Okay, questions? Next one. Okay. Sorry. So you got your time. Ten seconds. Okay, any questions? So Ms. Wong, are you done? Yes, thank you. Okay, this is Chebyshev inequality. Okay, Chebyshev inequality. So mu is equal to 40 and sigma square is equal to 81. So what about sigma? Standard deviation is equal to 9, right? Standard deviation is equal to 9. So you are required to find the probability of X between 67 and 13. Okay, and the other one is beyond beyond 58 and below 22. Okay, so how to deal with this question? Because if you remember, for Chebyshev inequality is absolute value of x minus mu x less than or equal to k sigma x, the probability has to be at least greater than or equal to 1 minus 1 over k squared, right? 1 minus 1 over k squared. So then you have to try to match the formula there. So we get x minus 40 will be less than or equal to 29, okay? Here, 67, okay? Plus 3 times 9, how much is that? 3 times 9 is equal to 27, right? 27 plus 40, okay? 27 plus 40 is equal to 67, right? And 40, okay, minus 27. 40 minus 27, that is equal to 13. Okay? So you have to match the formula there. The formula say x minus mu x. Okay, less than or equal to k sigma x. Okay? Less than or equal to k sigma x. So you have mu is equal to 40. So you have to have x minus 40. Okay? So this is the first part. So 67 minus 40, how much is that? 67 minus 40, how much is that? 27, right? 13 minus 40, how much is that? Negative 27, okay? And 27 is equal to how much times 9? 3 times 9, right? So k is equal to 3, okay? So when you apply this formula, you need to match part by part, x minus mu x and k sigma x, okay? So because of this, you know that how much is k? K is equal to 3. And so the probability is at least 1 minus 1 over 3 square. So 1 minus 1 ninth. So how much is that? 8 ninths. Okay, 8 ninths. Okay? Questions? 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 No questions. Smile, that's good. Okay. Okay, this question, 58 and 22, right? Okay, so the same thing. 58 minus 40, how much is that? 18. And 22 minus 40, how much is that? Negative 18, okay? So it is 2k, right? It is 2k. But remember, when you have the first part here, right? Okay. Okay, here, right? Okay, x minus 40 less than or equal to, okay? But here, it is different. It's greater than or less than, right? Greater than or less than. So it should be, the probability should be 1 over k squared. And you know that how much is k? 2, right? So it is 1/4. So it is 1/4 or 1/4. Okay, questions? So this is one example of the Chebyshev inequality. Okay, next one. So the distribution of x is as follows. So you have x, and the probability of x is 1/5. So basically, this is uniform distribution. Okay, in chapter 5 we will talk about this uniform distribution. So you are required to get expectation x, variance of x. Okay, and y is equal to x squared plus 1. You are going to find expectation of y and variance of y. Basically, that's all the same. Okay, so I don't want to do this again. So we have done this kind of examples so many times. Okay, so I will give you 20 seconds to take down this question. And then we will turn to the answer. Okay, so you take down the answer and go home and practice on your own. So you are required to calculate expectation of x, variance of x, and expectation of y and variance of y. Okay, questions? Okay, everyone done? 10 more seconds. Okay, the answer, expectation x is equal to 2, variance of x is equal to 2, expectation of y is equal to 7, variance of y is equal to 34.8. Variance of y is equal to 34.8. Okay. Please take down the answer only, okay? We won't have time to let you take down everything. Expectation x2, variance of x2, expectation y7, variance of y 34.8. Okay. So x is a random variable. Its mean 42, standard deviation 5. If w is equal to 3x plus 2, please find expectation w squared and variance w. You know, basically all the same, right? So I'll give you 20 seconds to take down this question, and then we will turn to the answer, take down the answer then. Okay. 10 seconds. Mean 42, standard deviation 5, W is equal to 3x plus 2, find expectation W squared, VW. 5 seconds. Okay, done. So the answer, expectation W squared 16609. Okay, expectation W squared 16609. V of square 225. V of W 225. Okay, another question. So we have 4 candidates in a campaign, and a poll shows the following support rate for the candidates. Okay, so we have A, B, C, D, 4 candidates, and of course among the constituents, okay, constituent means the voters. The voters, they are male and they are female. Okay, so if a person supports A, what is the probability that this person is a female? Okay, so the girl there in black strips. So if a person supports A, okay, what's the probability this person gonna be a female? Conditional probability, right? Excuse me? 0.15? Are you sure? We already know this person supports A, right? What is the probability that this is going to be a female? Your turn. I think this should be very simple, right? So, what should be that equal to? 0.15 over 0.35, right? Okay, good. So if a male is chosen, what is the probability he supports D? We already choose a male, okay? What is the probability he will support D? Exactly. 0.02 over 0.57. Okay, questions? Questions? Or anyone need more time to take it down? No one? Okay, 10 seconds. Five seconds. Anyone need more time? Okay. Done? Okay, good. Okay, there are 10 students. Okay, take statistics. Their scores are the following. Please find the average and the variance. Okay, this is just easy. Get a whole bunch of numbers and take that down. Okay, so I mean this is just a very simple exercise. Okay, in the book, a lot of homeworks. Okay, so I don't think you need to take it down. Okay, so basically this is one of the questions that we have before in the last year's midterm. Okay. Okay, this question, you have probability A is equal to 0.6, probability A given B, 0.6, and probability B given A, 0.3. So please find, I think I have done something wrong, okay? It should be find A and B, okay? Find A and B, okay? And then the second question is, are A and B independent? Okay, your turn. So the girl in purple suit. So are A and B independent? Are A and B independent? Yes, why? So your answer? Next one. Gentlemen, your turn. Next one. Okay, your turn. Lady. You know, it's very easy to see they are independent because PA is equal to PA given B. So whenever, I mean, it doesn't matter if you know B happens or not because PA is equal to 0.6. PA given B is also equal to 0.6. Remember when we say PA is equal to PA given B, what does that mean? That means they are independent, right? Of course you can show that because PA is equal to PA given B. PA given B is PA and B divided by PB, right? And so then you have PA times PB is equal to PA and B, okay? And of course, if you know PA given B, I mean, if you know A and B are independent, right? So what is PA and B? PA and B should be equal to PA times PB. And here, because we already know A and B are independent, right? So PB given A is equal to PB, right? So PA and B must be equal to 0.18, okay? So here, PA given B is equal to 0.6, and that is equal to PA and B divided by PB. So what does that mean? That means, I mean, here, there's something wrong here, okay? So you don't want to check down everything. I need to check that again. But basically, that's what I said, okay? PA and B must be equal to, down here, right? 0.18. And A and B are independent, okay? A and B are independent. Okay, questions? There is something wrong here. Don't take everything down, okay? There's something wrong here. Okay, another question. So we have A, B, C, D, 4 factories. The probability of choosing factories are 0.2, 0.3, 0.4, and 0.1 respectively, okay? And the rates of defective products for each factory 0.03, 0.04, 0.05, 0.06. So basically that's the same thing, right? We have the first question say we have A, B, C factory. The probability of choosing A, B, C is 0.2, 0.3, 0.5. And the defective rate, you know, the same thing. So then I'll give you 10 seconds to take the question down. So you have A, B, C, D, right? The probability 0.2, 0.4, 0.1, okay? And then the defective rate 0.03, 0.04, 0.05, 0.06. And so choosing any product from these factories, what is the probability that it is defective? Okay, your turn. So what's the probability that it's going to be defective? Excuse me? Okay, Miss Dunn. What's the probability if choose one? What's the probability that is going to be defective? it will be 0.2 times 0.03, right? Plus 0.3 times 0.04 plus 0.4 times 0.05 plus 0.1 times 0.06, right? Okay? Okay, if this is a good one, okay, now the question is a little bit different. If this is a good one, what is the probability that it comes from A? So because what we just know is it is a bad one, okay, so now you are going to get what's the probability that is the good one, okay, and then of course basically that's the same thing, Bayes theorem, okay, Bayes theorem. Okay, we don't want to spend too much time on something that we have gone over for many times. Questions? Anyone needs more time to take the question down? Yes or no? Yes, okay, 10 seconds. Okay, 5 seconds. Okay, need more time? You've got to learn shorthand, okay, you've got to learn shorthand. Okay, here, okay. So now this is another question. So we have a table here. So x is equal to 2 and 4. Y is equal to 1 and 3. And so you are required to find expectation x, variance of x, expectation y, variance of y, covariance xy, rho xy, are xy independent. You know, the same thing again. Okay, the same thing again. So give you 10 seconds to take this down, and then we will get to the next question. So 10 seconds. Yes. Excuse me? Sure. What about we, after people take this one done? Okay, after people done with this. Okay, everyone done? Everyone finished? Anyone needs more time to take this down? Okay, let's get to the answer for the last question. So it is here. You are not taking it down, right? Oh, sure. Okay, division of labor, yes. Any questions? Ten more seconds. I suppose you just take down the answer. Don't take down everything, okay? 10 seconds. 5 seconds. Okay, we'll get to the next one. Oh, so we are done. Okay, so sounds like we have done much faster than I expect. Any questions? No questions? Let us stop here.